Okay, so in this video, we are going to look at how we can apply the same concept to calculate for the center of mass of a 3D structure. Okay, so looking at this structure, it consists of two main shapes, which is a triangular prism, the A, and the cuboid, the one labeled as B. The formula to locate for the coordinates of the center of mass would be x bar is equivalent to summation of x curve multiplied with the mass divided with the summation of the mass. Okay, so the same concept applies for the y bar as well as the z bar coordinate. Okay, so based from this formula, here are the things that we need to look for. The first one is we have to identify what is the mass of every single shape, and then we have to sum it up. And then what is the coordinate of the centroid, x curve, what is the coordinate of y curve, and also what's the coordinate of the z curve. Okay, then only we can calculate the centroid of the entire body of x bar, y bar, and also z bar. So let's first solve for the first part, which is part A. Okay, already given in the question the density for both part. Okay, part A and part B have different magnitude of density. So if you recall from your kelas fizik suatu ketika dahulu, so density is equals to mass divided with volume. Okay, so therefore in order for you to get the value of mass, okay, you just rearrange the equation. So the mass is equivalent to density multiplied with the volume. Okay, now in this case, looking at the volume of the triangular prism, okay, we are going to label it as VA. It will be macam luas kerata rentas darab dengan tinggi. So luas kerata rentas is a triangular shape kan. So setengah kali tapak, the tapak is 6 meter, okay, given the dimension is in meter, and the height is another 6 meter over here. So the tinggi, the extruded height is 2 meter. So you use your calculator and get the volume of block A to be 36 meter cube. Okay, because it's a volume, so that's why it's in meter cube measure. Okay, now that the volume is done, then only you can calculate the mass of part A. So using the formula, mass is equal to density multiplied with the volume. So given that the density is 150 megagram per meter squared. So the thing is, you need to change the unit to SI unit. So megagram is not an SI unit. So to remove the mega, you have to multiply it with 10 to the power of 6. Okay, ini chapter 1 static dulu. Okay, and then if you need to insert the kilo, and then you have to multiply it with 10 to the power of negative 3, okay, kilo. Once that is converted, then only you can multiply it with the volume. The volume is 36 meter cube. Okay, now from this formula, the meter cube and meter cube is cancelled. The only remaining value is the kilogram. So you use your calculator and you will get the mass of block A to be, wow, that's a big value, 5,400,000 kilogram. Okay, now we have to locate the centroid of this triangular prism. Okay, so if you were to redraw the block from the perspective of z axis into the dimensional view, so this triangle would be the cross section of block A. Okay, and then don't forget the cross section of block B, which is this area. Okay, the centroid of block A would be 1/3 from the base and also 1/3 from the height. Okay, so 1/3 from the base is 6 meter, so 1/3 from 6 is 2 meter. Okay, don't forget the length coming from this block B is another 2 meter. Okay, so therefore the centroid location along the x direction, the x curve, would be 2 plus 2. So the coordinate of centroid for block A would be 4 meter. Okay, now we know that the total height of this block along the z direction is 6 meter. So therefore, the location of the centroid from the origin and along the z direction will be 1/3 of its height of 6 meter. So the z curve would be 1/3 multiplied with 6. So it would be equivalent to 2 meter. So the coordinate of the z curve for block A would be 2 meter. Okay, now accordingly, the center point for the y curve, so y-axis is over here. So if you look, the thickness of block A is 2 meter. So the middle point between 2 meter would be 1 meter lah from the origin. Okay, so the y curve is 1 meter. Okay, now we need to multiply each centroid coordinate with the mass. Okay, so x curve multiplied with m, 4 multiplied with 5,400,000 kilo, you will get a value of 21.6 times 10 to the power of 6. So y curve multiplied with n, accordingly you will get a value of 5.4 times 10 to the power of 6. And the value of z curve multiplied with m, you get a value of 10.8 times 10 to the power of 6. Okay, sebab saya malas nak tulis kosong 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 banyak kali, so I just use a 10 power of 6 kind of expression. Okay, now that's done, let's solve for part B. Okay, so in part B, we have to look for the volume of part B or block B. So the volume is luas keratan rentas darab dengan tinggi. So 6 multiplied with 6 multiplied with the height of 2. So you will get the volume of part B to be 72 meter cube. Okay, so from this volume, you can then calculate the mass of block B. So it will be equivalent to density of block B multiplied with the volume of block B. So given that the density of block B is 400 megagram per meter cube. So sama je macam step sebelum ni, you have to convert the megagram into an equivalent kilogram. So darab 10 kuasa 6, darab 10 kuasa negatif 3, and then you can multiply with the volume of block B to be 72 meter cube. So we will get a corresponding mass of block B to be 28.8 times 10 to the power of 6 kilogram. Okay, so now accordingly, because this is a block, this is quite easy to determine the x curve, y curve, and also the z curve coordinate. Okay, so if you look at this block, along the x direction, the thickness of this block is 2 meter. So therefore, the centroid would be located in the middle between 2 meter, which is 1 meter. And then along the y direction, the length of this centroid is 6 meter. So half of 6 would be 3 meter. Okay, accordingly along the z direction, the height of this block is 6 meter, so half of 6 meter would be 3 meter. Okay, then accordingly you have to look up for the multiplication of the centroids to the mass. So I'm going to go through this part very fast because you should repeat the same step as the previous one. And now that's done, I can organize my information in the table nicely lah. Okay, so the first column of my table would be the segment of the block. Okay, the second column would be the mass of each block, and the third column would be the multiplication of the x curve with the m, and the third column would be the multiplication of y curve with m. And since this is a three-dimensional kind of problem, so the final column would be the multiplication of z curve with the m. Okay, so now accordingly I'm going to put all the necessary information in my table. So I know there are 2 blocks or 2 segments in this particular body, which is segment A and segment B, and put on all the information that I've calculated earlier. Then the next step is to sum up every single thing in each column. Okay, so the summation of mass, okay, sama je, is 34.2 times 10 to the power of 6. The summation of x curve multiplied with m is 50.4 times 10 to the power of 6. The summation of y curve over m is 91.8 times 10 to the power of 6. And the summation of z curve to m is 97.2 times 10 to the power of 6. So now all the information is ready. I can finally solve for the centroid of the body, which is the x bar, y bar, and z bar, based on the formula that I have defined earlier. Okay, so the x bar is equals to summation of x curve multiplied with m divided with the summation of m. So based on the table that we have constructed earlier, the summation of x curve m is 50.4 times 10 to the power of 6, and then divide with the summation of m is 34.2 times 10 to the power of 6. Okay, simply use your calculator and I will get a value of x bar to be 1.4737 meter. Okay, now repeat the same step for the y bar. Okay, the formula is already given. You try to do this on your own and you should get the magnitude of the y bar to be 2.6842 meter. And accordingly, z bar formula is also given, and calculate it on your own, and you should get the magnitude of the z bar to be 2.8421 meter. So these are the coordinates of the center of mass for the given block. Okay, dah siap? Okay, so now let's look at a more realistic and applied kind of example. In this example, you are required to locate the center of mass of a compressor assembly. So this assembly is made up of multiple components and the masses are given in the figure. So if you look very carefully, the compressor assembly is made up of an instrument panel, a filter system, a piping assembly, the liquid storage and the structural framework. So if you look at the diagram, even the centroid of each component are also provided. In this question, you are also expected to find and calculate the vertical reaction at point A and point B. So, if you look carefully, there's like a base at point A and point B to support the compressor assembly. Okay, now if you want to find the coordinate of the center of mass, okay, in the x direction or the x bar, the formula is summation of x curve multiplied with the mass divided with the summation of the mass. Okay, accordingly, the coordinate in the y direction or the y bar will be equivalent to summation of y curve multiplied with the mass divided with the summation of the mass. Okay, now we are going to fill up the table with the necessary information. Okay, I already constructed the table earlier so that my video wouldn't be that long. So the first column of the table will be the components, which is labeled as 1 to 5. And then the second column will be the mass of each component. The third and the fourth column is the centroid coordinate of each component, which is the x curve as well as the y curve. Okay, and the final column is the multiplication of the centroid coordinates with the respective with the mass. Okay, the mass of each component is already given here, so I'm going to quickly fill up the given mass respective to the components. So for example, component 1, instrument panel, the mass is 230 kilogram. For filter system, the mass is 183 kilogram, and so on and so forth. And now we are going to fill up the following column with the centroid of each component. Okay, so if you look at component number 1, which is labeled here, okay, the centroid along the x direction or the x curve is 1.8 meter. Okay, and accordingly, the centroid along the y direction or the y curve is 1.2 meter. Okay, as for the second component, the x curve will be from here to here. So you total up the distance and the coordinate will be 5.91 along the x direction. Okay, along the y direction, the distance will be this one lah, which is 4.83 meter. Okay, so you just fill up the following rows accordingly and this is what you will get. Okay, as for the following column, quite easily, you just multiply the mass with the x curve. 230 multiply with 1.8, you will get a value of 1.4. Accordingly, you need to multiply the mass with the y curve as well. So, 230 multiplied with 1.2, you will get a value of 276. Okay, so you just fill up the following rows with the multiplication of every single components. Okay, so finally, we need to sum up the masses and also the multiplication of the masses to each centroids. Okay, so summation of the mass, which is 230 plus 183 plus blah 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 blah, you will get a total mass of the assembly to be 1086 kilogram. Okay, so and then what are other information that you need? Okay, you need to also sum up the multiplication of x curve to m. Okay, so 414 campur 108 1.53 campur 1053 and so on, you will get a total value of 4953.59. Okay, and finally summation of y curve with m, which is a total summation of all this value in this particular column, you will get a value of 3338.09. So you just use all this information to calculate our center of mass. So based on the formula that we have drawn out earlier, so x bar is equivalent to summation of x curve multiplied with m, which is 4953.59, divided with summation of mass of 1086. Okay, so use your calculator and get the x bar to be 4.56 meter. Okay, so you do the same for the y bar as well. Just put in the value that you have calculated earlier from the table and you will get the y bar to be 3.07 meter. Okay, now for the second item requested in the question, we are going to look for the magnitude of the reaction force at point A and also point B. Okay, so if I were to redraw the entire assembly as a single component like this, so this is my compressor assembly, which is placed onto top of a support system, and there's a stand of A and stand of B over there. So we want to find what is the vertical force of AY and also BY. Okay, so we know the total weight of this compressor is acting downward at the center of mass. Okay, so the weight is equals to mg, and the total mass of this assembly, we already calculated it from our table, which is 1086 kilogram. So you have to multiply this value with the gravitational acceleration of 9.81 to get the weight of the entire assembly. So the weight of the assembly is 10,653.66 Newton. Okay, based on the original diagram, the x-axis would be along here and the y-axis would be along this direction. Okay, so this point is let's call this point as point O. Based on our calculation earlier, okay, the center of mass is 4.56 meter along the x direction. So from point O, the x bar is 4.56 meter like this, okay. And accordingly, along the y direction, we already calculated the y bar to be 3.07 meter. So this is the position of the center of mass. Okay, so basically you have actually drawn the free body diagram of the compressor assembly, and if this is a free body diagram, then you can solve this kind of problem using an equilibrium condition. Okay, so based on this diagram, you'll notice that there are two unknowns in the system, which is the AY as well as the BY. So if there are two unknowns, then you have to solve this problem with two equation. Simple. The word equation je is required. Okay, so consider the system to be in equilibrium condition. So we are going to apply the equilibrium for moment at point O, okay, at the origin. So summation of moment at point O is equivalent to 0. So this force, this weight, will create a moment, downward moment, at a distance of 4.56 meter. And if you plot the rotation along point O, it will create a clockwise kind of motion. So the magnitude is negative. Okay. Accordingly, this By will also create a kind of moment as well. So the force is By, and the distance is, if you look at the original diagram, the total distance from origin point O to point B is 10.42 meter. Okay, you calculate it on your own, and if you draw an imaginary circle along the rotation point O, you will get rotation to be counterclockwise. So this magnitude is positive. So there are no other forces which will create moment. This will sum up to 0. So as there are only one unknown in this equation, you can conveniently solve for the By. And the magnitude of the By is 4662.25 Newton. So you already got the vertical force at point B. Okay, now you can proceed by applying the equilibrium condition in the y direction. Okay, so you know that there are three forces acting in the y direction. The first one is the weight of 10,653 Newton, which is acting downward, negative. And then there's a AY, and there's also the BY. So you put all that forces in your equation. Okay, By we already calculated earlier, so you just substitute the value of By of 4662 into here, and finally there will only be one unknown, which is the AY. So conveniently you can solve for the AY forces to be 5991.08 Newton. Cool. So that is the vertical force at point A. So you're done. Dah siap. Okay guys, that is the end of the course, amazingly. So I really hope that the provided video lecture really helped you in understanding the concept of engineering mechanics, especially in the topic of statics. It is a challenge to conduct classes like this in online mode. Okay, I admit that there are many shortcomings from my side. I deeply apologize for all the inconvenience caused. Anyway, all the best for your final exam, and probably we will meet again, inshallah, for a different course. Okay, till then, remember to keep the spirit of learning high up, okay, regardless of whatever may happen in the future. Okay, till then, sayonara.